All right, welcome everybody to a day of linked lists again. Today we're going to be talking about circular linked lists. We're going to start off with a little coding problem. It's going to be worth 3 points. It'll count as your quiz for today. So if you have a doubly linked list, and let's just say you're in the middle of it. Don't worry about size. You're just like in the middle somewhere. Like maybe there's a billion nodes off that way and a billion nodes off that way. And you've got a pointer called PTR, or putter as Arthur Dwyer pronounces it. You got a pointer here, and you want to delete this thing. You want to eliminate Lewis from existence. Okay, so yeah, the good news is it's 3 lines of code. Okay, so you're going to have 5 minutes to write 3 lines of code. I want all of you guys to start streaming, connect to the server right now, and just open up like a blank file in Vim. And I want you guys to write 3 lines of code to delete from the middle of a linked list. You've got a pointer there already. You don't have to search through the list. It's similar to like your pop function. It's going to be deleting stuff. Head isn't going to change. Tail isn't going to change because you're deep within the middle of it. There's a billion to the left. There's a billion to the right. You've already got a pointer there. 3 lines of code. How do we delete Lewis and clean up the pointers around it successfully? You have 5 minutes. Start streaming on Discord and begin now. And welcome back. So, like I said, whenever you work with linked lists, it's very helpful to actually have a picture on the screen so you can kind of see what's happening. So, the way that new and delete works, this is something that a lot of students kind of struggle with. Like in the previous class, they're asking, well, if I had 2 pointers like at Lewis, the node containing Lewis, do I have to say both delete pointer and delete temp? And that that's not really how delete works. So how new works? Maybe we should talk about that. It's a data. It maintains a data structure of like which sections of RAM have been like reserved by you. And so like it might say, all right, this section of RAM here, that's this chunk here, and then there's another section of RAM over here, and that's this one, and it marks them as like used. Like these areas cannot be like reused until you call delete on them. And whenever you call new, it just like returns like a memory address, like memory address 700, memory address like 420, you know, memory address 500 or something like that. So when you call delete, you're just like pointers are just integers, right? And so if you said delete pointer, what you're passing in to delete is you're just passing in delete, the memory address 700, let's say. I mean, it's not going to be 700. It's going to be some absurdly, large 64-bit number, but I don't want to write it. So memory address 700 it is. And so when you say delete 700, what it does is it just marks this area of RAM as like, you can use it again. That's it. It just keeps track of which, like new and delete have their own data structures under the hood. They used to be implemented with heaps, which is why this area of RAM is called the heap. And what happens when you mark something as deleted, it doesn't touch the pointers. The pointers are they still, like pointer and temp, both have the value of 700 in them. The area of RAM here isn't deleted. It's not zero filled or anything like that. All that happens is inside of this internal data structure, delete just says, okay, that area could be used again. And maybe at some future date, new will repurpose that RAM and like allocate it to like a new linked list, right? Like you call new sometime down the road, that size of that chunk of RAM exactly fits, the new node. It might repurpose it, but in the meantime, like that RAM is still just there. All the values are still there. It doesn't zero fill it. It doesn't delete it. So if you were to call like delete pointer and delete temp, you would have a double free. What happens is you would delete 700 and mark it as free. And then when you try deleting temp, it would come in here and say like, oh, whoa, that area has already been marked as free. And you'll get what's called a double free and it'll crash your program. So that's kind of what's happening when you have news and deletes. Under the hood, all it is just keeping track of like which areas of RAM have been reserved by you. And when you call delete, it just says, okay, that RAM could be used again. And that's it. It's just a pretty simple routine. So how do we delete this stuff? All right. So you guys all are putting your delete last. Don't do an array delete, Hawkman. So if you have the brackets there, the brackets are only for doing an array delete. And the reason, it's kind of a dumb reason, honestly, because like the new and delete system could honestly like track this, but there's a separate deleter for arrays, and it's called delete square bracket, I guess. There's probably some more technical term for it. And that handles if you've got like a bunch of things, like 10 things, then the bracket delete will come through and like unallocate all of those things in order. Delete only deletes one thing, array delete deletes X in elements, whatever. And there's probably like some optimization reason why that is, and it's probably a good idea that there's a separate one, but it is kind of janky because they could have just, you know, had the array deleter and the regular deleter, I don't know, kind of work the same way or something. Good. We are all deleting things last, mostly in our code up here. Yeah, so Mossad, yeah, you don't need to check to see if the next and the previous are null. You don't, and some people have head, some people have tail, at least when they're doing the development. No, I told you guys, you don't have to worry about any of that. You're just in the middle of a list. There's a billion elements before you. There's a billion elements after you. Okay? So what you need to do is, very good, Ella, is something like this. So putter points to previous, points to next, equals pointer points to next. Pointer points to next, points to previous, equals pointer points to previous, delete putter. And so what this does, that's actually pretty much exactly what I wrote in class today. So you've got pointer points to previous, and that is this guy. So this guy here we can call pointer points to previous is a pointer at this guy, right? Pointer points to previous is this thing here. It's pointing at Voss, okay? And so what we're doing is we're setting pointer points to previous as next. That is this pointer right here. This pointer is going to be set equal to pointer points to next, right? Pointer points to next is this pointer here. It's pointing at Kearney. And so that's setting the next pointer to point at Kearney. And then we're doing the same thing the other way around. Pointer points to previous, which is Kearney. His previous, sorry, pointer points to next is Kearney. His previous is this pointer here. That pointer is going to be set to our previous. Pointer is next, that's Kearney. His previous is equal to our previous. And so it's copying the value in here is 500, right? The value in here right now is currently 700, but we're going to copy the value of 500 over. And so now the previous of Kearney is Voss. And the next of Voss is set to 420. So after all these lines of code run, Voss's next is 420. Kearney's previous is 500. The Lewis node has been bypassed successfully. Like this, all the arrows work, and then you call delete on pointer. And when you call delete on pointer, it just marks that memory as freed, and you don't have any problems. So that is the correct answer there. Okay. So all of this will be graded if you are watching or recording. Yeah, sorry, should have been in class today. It's a synchronous class. Okay, we don't do these often, but I did notice a trend in this class for people just not submitting code during lab time, and I want you guys to try, even if you fail, because learning through failure is like one of the best ways of learning. And if you're worried about your grade, then there's going to be plenty of extra credit workshops. We're going to have one on like the Japanese language, I think, next Friday and stuff like that. So don't beat yourself up if you did poorly on it. I've been entering the grades for the previous section, and none of them got it correct. So more of you guys got it correct than they did. I'm not fully done grading it yet. I'm only halfway through it, but yeah, the performance is not great. So we'll previous point to next, and next point to previous. So Lewis's previous is, so putter points to previous is Voss. Okay, so when you say pointer points to previous, that is the node pointing at, it's a pointer pointing at Voss. When you say Voss is next, it's this guy here. And so his pointer is equal to Lewis's next. And so what we're doing is, yeah, if you don't have the delete, the linked list will still work. It'll be correct, but you've leaked memory, right? And you don't want to leak memory. And so you have to clean up the pointers is the important thing, so that you don't segfault or whatever. But the deleting is also important so that you don't have memory leaking around. So yeah, if you guys did poorly on it, don't worry. I told you guys, pointers are the hardest thing in CSI 40 and 41. It's just always been that way. It just takes a while to get the experience with them, to have it feel natural and just realize they're not really a big deal. It's like calculus. It's like after you learn calculus, a derivative is not, a hard concept, but it's kind of like wrapping your mind around, okay, so a derivative is the slope. And so what's an integral? An integral is like the opposite of the slope. How do you have the opposite of a slope? And like conceptually it's hard, but then after you get the concepts, it's not too bad. And everybody goes through it. Everybody goes through it. And so Minkrelli and I have been working on a sort of amnesty plan. We were consulting with each other last night and coming up with an amnesty plan for you. And the plan is this. I don't want to just give extra credit for to make up missing homework assignments, because I actually want you to do the missing homework assignments. Like, none of the homework assignments we do in this class are just like for fun, for funsies, right? Like every homework assignment I give in computer science is designed to teach you a concept. And if you don't learn that concept, then you're going to be toast, right? Imagine coming into CSI 41 and not knowing like branches or for loops or something, right? Which is actually something I've seen a lot of students struggling with. That's not good. You're not going to succeed in computer science if you're not good with for loops, right? And so what we put together is this idea. So if you're weak on for loops, I want you to go back and do the complete Zybooks chapter on for loops. Everything, every question on it. It's a lot of work, I know, but it's better than like being ignorant, right? And like trying to just plow through with your computer science career, not knowing like what an else is, or like a function call or something like that. Like your computer science career will not be very long if you don't know how to make a variable, how to do a if statement, how to do a for loop, how to do a function. Range-based for loops are pretty important to you. Like it's not going to go well. It is a train wreck on top of a train wreck. And so the offer is this: if you do the complete Zybooks on a chapter on something that you're weak on, then you will gain the ability to make up one of your missed homework assignments. It's not giving you the credit for it, because then you would just do the 40 stuff and get credit for 41, which we don't want. We want you actually doing all the work in 41 and learning linked lists and learning, how to do class design and the other topics we're coming up with. So basically, it's a way of kind of like earning an extra last chance. Okay. And so if you have any zeros in your homework assignments, then do an entire chapter of the old Zybooks, and then you will have the opportunity to turn in do one of your missing homework assignments in this class, because all of them are important. Okay. You do it even if you're not weak in a subject. Yeah. I'm allowing you to just pick any topic you want. The details will be on Canvas. If you just had something up, you didn't manage to do an assignment. Yeah, like you just do one of the chapters, right? Because I don't want to just be like, oh, you can just turn an assignment anytime you want. I tried that in IS 50 a year and a half ago, and like I had one student just wait to finals week and did all of the homework assignments during finals week, and I'm like, you didn't learn anything, So deadlines are there for a reason, and so it's gonna be fairly painful it'll be a lot easier to just do the homework. Let's put it that way. Okay. Available through the whole semester only now. The plan is you'll see the details on Canvas. The answer to that's a little bit complicated. But like as of right now, you'll be able to make up any of your missing ones, and then going forward, it'll give you essentially an extra week to do something in the future. In part because we have a long weekend coming up, and I want you guys making up any of your missing work there. Okay. So today we're going to be talking about circular linked lists a little bit, and then we're going to be moving into inheritance. So let me put this linked list back into shape here. We got a lot of switches on the screen. Okay. So let's say this is head, and this is, let's make one more node for the tail. So 3 is a little bit small. And this will be Eggert. And so, let's clean this up here. Okay. So the pointers are going to be looking like this to begin with. So what we're going to do is when you make a circular linked list, it is very close to a regular linked list. Okay. So we got head at the front, and then we got tail at the back. Okay. Our grades for imaginary homework in, they are, I've graded them all. I'll check on that though. So, okay. So with a circular linked list, the only difference from a regular linked list is right now the previous of head is null and the next of tail is null pointer, right? With a circular linked list, it looks like this instead. The tail next is the head, and the head's previous is the tail. So if you just keep going next, you'll go Voss, Lewis, Kearney, Eggert, Voss, Lewis, Kearney, Eggert. This is actually a really good data structure. If you have like, instead of null, it's not null anymore. If you go off the end, you wrap around back to the head. And if you go previous to the head, you wrap around to the tail. This is actually really useful if you're doing like a board game or something like that, or for your RPG 41 homework assignment, you're going to implement like a turn order, right? So everybody's going to be in turn order. And then when people die, you're going to do code very similar to what you did today, where you're going to like delete a person out, fix up the pointers around it. So basically, as the combat goes on, monsters will get eliminated, players will get eliminated, but it'll still just go around in a circle like that. It's like an initiative tracker. You still have head and tail, yeah. I mean, technically, you don't need a tail because you could always just say head points to previous, but typically, yeah, because you're probably going to still have a head and a tail, so you can insert at the end and push at the front, stuff like that. It's useful if you have like a menu, like if you have like in a video game, like you've got attack and item and spell and things like that. You press down, 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 down. When you get to the bottom, you hit down again, it goes back up to the top. But if you want to add something to the bottom of the list, then you append to the tail, you know. Yep. And so the question is, how do you write a for loop that detects when you've printed out everything in the list? And so it's a little bit different than before. So before you'd have a pointer that points to head, and you say while pointer is not null, pointer equals pointer points to next. So to start off with, the pointer is pointing at head, it's not null. Okay, so pointer equals pointer points to next, pointer equals pointer points to next, pointer equals pointer points to next, and it just sits there and iterates down the list. And then normally tails next is null, and then eventually pointer will be equal to null, and then the for loop says done. With this, it's a little bit different. Instead, you say go until pointer equals the head again. So after you've done the pointer equals pointer points to next, you check to see if you're back at the head. So you start off with the pointer pointing at the head, you go to the next, you go to the next, go to the next, and then when you go to the next again, you're like, oh, look, we're equal. And it breaks. So it's a small change. You have to be careful not to break at the very beginning, because the very first time through it, pointer is equal to head, right? And so you have to be a little bit careful. But basically, you just go to the next, and if, like you use just a while true loop, right? You do your thing. Like, let's say we're changing everyone to be uppercase. Like, you uppercase Voss, then you say pointer equals pointer points to next. If the pointer is now equal to head, break. Otherwise, while true. You know, and you just sit there and you uppercaseify everything, and then eventually the pointer equals the head again, and you break out of it. So that is a circular linked list. Check for condition at the end of the body. That's what I would do. I wouldn't use a for loop necessarily. I'd probably use I'd just use a while loop. You know, do something. Did I close out a putty? Yeah. I would just do something like this, like while, okay, while true. Node pointer equals head. If not head, might return or something. Obviously, don't have my linked list class in here. I'm just showing you guys. So pointer points to data uppercase fi would be a function that doesn't exist that would uppercase the string, and then we would say pointer equals pointer points to next. Shoot. There we go. Okay. Pointer equals pointer points to next, and then if pointer equals head. So your Zybooks is going to talk about circular linked lists, so that'll probably help conceptually. And this isn't going to be in main. This is going to be in like your linked list class or something, right? But this is kind of, I'm just kind of sketching out what the code will look like. You start off by creating a temporary pointer, set it equal to the head. If head is null, you bail out. And then you just loop across the whole thing. You uppercaseify the string. This function obviously doesn't exist. You would have to write it. They would set all the letters to be the uppercase version of the letters. Settle uppercase Voss to be Voss, you know. And then pointer equals pointer points to next. And then if we hit the head ever, we're done. So that's a code pattern for circular linked lists. You could track, if you track size, you could do a for loop where you just loop over the size. Absolutely. Always different ways of doing things. So. All right. So that brings us to the end of linked lists. You're going to have the current homework assignment and the next homework assignment to work on linked lists, and then you're going to get a competency exam on it. So we will probably do more of these quizzes until you've really got the linked list knowledge hammered into your head. It's a painful process, but like I said, if you try and fail and then learn it, you learn it a lot better. It's actually just solid cognitive science. Trying and failing and then seeing how it works is actually a really good way to learn. All right. So we are going to talk about inheritance now, because you're going to need that for your RPG 41 assignment. So, sinking ship. Yeah. So, inheritance is, this is kind of the core concept of inheritance. Inheritance allows you to copy and paste from another code to make a new, copy and paste from another class to make a new class. Okay. So, this is a core part of object-oriented programming, OOP. Oops. Object-oriented programming is kind of what we've been focusing on this semester in CSI 41. In CSI 40, we focused on something called procedural programming. In procedural programming, all the brains are in main, right? So, if you were doing like complex numbers in CSI 40, you would probably have a variable for the real part and the imaginary part for maybe 2 variables. And then, so you'd have 4 variables total, and you'd like add the 2 real parts together and add the 2 imaginary parts together and print out the result, real, plus imaginary plus I. And if you did multiplication, all of it would be in main. You just do the foiling in main itself. For this class, though, you're writing code like this. That right there is an operator, right? That is operator plus. And so the brains, like the knowledge of how to add complex numbers, are not in main. Main doesn't need to know anything about how complex numbers work, which is nice. There's a separation of concerns. All of our information about how complex numbers work are actually found in the complex class. And so inside of the complex class, there is a plus operator. And the plus operator tells us everything we need to know about adding complex numbers together. And so all of the brains are actually out in the complex class or in the other classes, the imaginary class. If you make a rectangle class, everything you need to know about rectangles is in the rectangle class. Main doesn't need to know anything. And so that's the kind of the core concept of object-oriented programming, is that all of the intelligence is actually out in these classes. And main, like sometimes main will literally just be like, it'll just like make a variable and then just say Bob.begin. And that's literally all of main for like World of Warcraft or something like that. Like, you have some immensely large program, and all of its main is just make an object. Like, it wouldn't be called Bob; it'd be called like game or something like that. And it just calls game.begin, and then that is where all the stuff is. Main is basically empty. There are a lot of very large programs like that. Depression up again. There are a lot of very large games like that where literally main is just 2 lines of code. Make an object, call begin. And then, so main knows nothing. I personally, I'm not a huge fan of that. I actually think main serves a purpose. It's sort of a philosophical disagreement I had with my old CSI 41 professor because I was sending my students to him. He just retired actually, but I was sending my students to him, and he was like not liking the code they were writing. He's like, you shouldn't have anything in main. Main should be empty. I'm like, bro, like, come on, like, it's a philosophical thing at a certain point. Okay, so what we're gonna do today is start. Yeah, you just hit the start button. Is there a benefit to doing it like that? You could have multiple games, I guess. I don't know. Not really. I mean, because essentially, like your dot begin is just main, right? If you have like command line parameters, like it's got to know about them now, and so I don't think a game class should know about command line parameters. That is something to me that should be handled in main. It gets philosophical at a certain point, and I don't drink fully from the OOP Kool-Aid. Let's put it that way. And inheritance is actually another example of this. So inheritance, a lot of people love inheritance. I am sort of lukewarm on it, but I'm going to show you when it's useful. So imagine you've got the iStream class. The iStream class, anyone know any variables of type iStream? And this pen is doing this thing. Anyone know any variables of type iStream? Not ice cream, iStream. Yeah, Cn. Cn is of type iStream, right? And so it's actually a pretty big class, right? Because like you've got like this operator double left arrow, and it has to know how to print out. It has to know how to print out like ints and like floats and doubles and chars and strings. Like it has to know how to print all these different things. There's a lot of code in there, and like for the reading in of things, for like iStreams, iStreams have to know how to parse numbers. Like so, if you type in like negative 3.1415, it reads one character at a time. It's like, oh, it's a negative. Okay, it's a 3. It's a dot. Oh, it's a decimal. What if you type in like 3.14.15? Like now there's 2 decimals in there, and like it's a crazy complicated thing. Like parsing input is like one of the most annoying parts of computer science, and so that doesn't even have all of it actually. Bittencourt. It doesn't have ifstream in there, and so what you want to do, like iStream is something like Cn, right? But like when you want to open a file, you have like an IF stream, a file stream, right? And what's really neat about it is that when you do this, when you do the :public, that means inheritance. This is how inheritance takes place. That right there. :public and then the name of the class you're inheriting from. What it does is it copies and pastes all of that code from iStream into ifstream for free. For free. So you do not have to duplicate your work. You don't have to repeat yourself. This is, what we call the dry principle, which is the don't repeat yourself principle, right? Don't repeat yourself principle. So if you've got 50,000 lines of code that like know how to read, very complex things like floats and strings and whatever, you don't want to do it again, right? You're done with it. And so by doing inheritance, you can have your IF stream get all of that code for free. And then all you have to do is just write the little bit of code that is different, right? So like a file stream, you have the ability to do something like this, right? You can see like IF stream ends is what I always call mine for whatever reason. File.text, right? You can't do this with Cn, right? But with an IF stream, you can. This will open up a file for reading. And so you have to have a constructor. This is a constructor. It takes a file name. And then this here is how you call the constructor on your parent class. So that initializes all the iStream stuff automatically for free. And then we're just going to call open on the file name. And then that opens the file for reading. We probably have to have some sort of destructor to close the file and stuff like that. But this is the basics of it, right? So The basics of it is that like we're just getting all of the iStream stuff for free, but the little bit that's different for like reading and writing to a file, we do here. So here we have just the differences. So 50,000 lines are copied for free. We have 100 lines of code to handle the file stuff that we actually have to write. It's really nice. Anytime, yeah, for free. You don't have to pay for it. So, yeah. So the nice thing about it is you don't have to repeat yourself, as I've said before. Okay, so yeah, basically all of its member variables, all of its member functions get copied over. You don't have to code them again. All you have to worry about is like the new functionality, right? Or if you want to change functionality, you can do that too. But like the operator double right arrow, the operator double left arrow, all those things just work out of the box. You don't have to do them again. And the really neat thing is that if you have a function that takes iStreams, you can pass an IF stream to it. When you do inheritance, if you've got like class A and from it you've got class like B and class C, any function that takes an A can take either a B or a C also. And so that's kind of neat. That's kind of a neat thing. Now there's a danger of something called slicing that we'll talk about later. But yeah, so here we got class A, and then class B inherits from class A. And so any function that takes an A can take a B. So that's just kind of neat. Some people go like whole hog on inheritance, and they have like to talk about a real life example, they have an actor class. This is an Unreal Engine, and inside of the actor class, there's like a pawn class. A pawn class is anything that can like take input, like mouse, keyboard, or game controller or whatever. And then inheriting from pawn, you have like a character, which is anything like the first person can be like you or the character, stuff like that. So the actual class hierarchy for this thing is like the org chart for like Tesla or something like that. Like it's this enormously complicated thing. And like I said, I'm kind of lukewarm on inheritance because anytime you need like a flow chart like that to like, what's the name of my class again that handles, whatever, and you have to like look at this poster that covers your wall, and you look like one of those conspiracy theorists, if the string's going this way. Then to me, that's not great design. A lot of times you just use a variable or a if statement instead. Okay, so let's go through how this works. Yeah, that's the one I was thinking of, right? If this is your class hierarchy, like I'm not a super big fan of this, right? Like yeah, I there are times when inheritance is needed, but my personal experience is that when people drink the OOP Kool-Aid, like they just go whole hog, and we're like, okay, we're gonna have monsters. We're gonna make World of Warcraft, and so every separate monster is its own class, and then we're gonna have a kobold class, and then all the kobolds are gonna inherit from the kobold class, and the kobold class inherits from the monster class. The monster class inherits from the actor class, and then each individual kobold for the people that have torches on their head or don't, like those are all separate classes, and like it ends up becoming just this giant maze looking thing. And some people like that. I mean, some people really get into that. My own personal take on it is to try and have as few classes as I can get away with. Yeah. Yeah, that's not even that bad, honestly. This is only like 1, 2, 3, 4 classes, really. That's actually not that bad. Yeah, let me see if I can. So they use like UML class design hierarchy. Yeah. So you're booking a reservation at a restaurant. So you've got a reservation, and the reservation connects to a loan, and there's penalties, and there's books, and like I don't like. Like these things get so gnarly. Yeah. So I mean, and this isn't even that many. Like all things considered, like it's actually not that many. Like you can have these things literally covering your wall. So yeah, like that's actually a good analogy, Megan, for like a class hierarchy because you've got oh wait, no, this isn't exactly what I was thinking of. I was thinking of more like the like tree of life or something like that. Where like you've got everything. You have animals inside of animals. You've got chordates, and there's somewhere there vertebrata, and then amphibians and arthropods and mammalia and birds and reptiles. Like this is a class hierarchy, right? And then over here you got I don't know plants and bacteria and some stuff like that. So that's a class hierarchy, right? Every human is a mammal. Every mammal is a chordate. Every chordate is an animal, right? So, okay. Yeah, broccoli. Did you hear that like Brussels sprouts were actually genetically engineered to like not taste bad? Like when I remember them as a kid, like they tasted pretty foul. And then I had them again as an adult, and I was like, oh, these roasted Brussels sprouts are amazing. Like I must have just grown up. But apparently, they actually genetically engineered Brussels sprouts to like not taste bad. Apparently, so sometime in the last 30 years or something. I don't know. Yeah. Okay. So we've got here. Let's just go through a basic example. Class A. What does it mean? Nothing. This is a stupid demo for you guys. So this thing here is actually a new learning point for today. And my pen is not working. My pen is not working now. All right. Okay. Anyhow, protected is a new keyword. Protected is the same thing as private, except it allows your children to have access to this member variable here. Okay. So let's try reopening the presentation. Maybe that'll fix it. There we go. All right. So this is just like private, but it allows your children to have access to it too. So, because remember, the rule for private is that nothing outside of the class can read or write directly to foo. You always have to use like getters and setters, right? And that's true even of your children. Your children are not your friend, and you cannot make children your friend. So, you guys are all talking about Brussels sprouts. Your children cannot be your friend. If you want your children to have access to foo here, you have to use the protected keyword. So it's like private light. Let's describe protected that way. So it's just like private, except your children can now read and write to foo as well. And which one is correct is it kind of depends on your own personal philosophy. Some people use private anyway. I tend to use protected. Again, my old CSI 41 professor is probably screeching right now. I don't know. But honestly, like there's some philosophical difference between private and protected. Like, should your kids be able to read and write it directly? Maybe not. Maybe they should. Maybe even your kids should use the getters and setters. There's probably a good argument to be made there, but in general, when I'm doing inheritance, I use protected. And then if I'm gonna break, I don't know, like it basically sort of like the low IQ way of doing inheritance is just use protected instead of private. Okay, just don't use private anymore. Use protected. There you go. And then when people complain about you philosophically, they're probably right. What's the sharp edge of using protected instead of protected? That doesn't. Oh, private. Okay, that makes a little more sense. So like, remember how like we said the whole point of privacy is so that like if you have an invariant, you can preserve the invariant, right? Like let's say that foo has to be in the range from like 0 to 100. If you have this thing be public, then main could change it to be 200, and you can't tell, right? And it violates your invariant. If you have it protected, your kids could violate the invariant. Am I worried about that? Maybe not. I don't know. Like maybe my kids would want to change the invariant to 200 anyway. It's kind of like one of those things. Like I said, it's kind of philosophical. It's like some people will just use private, and they're like, if the kids want to mess with it, they can use getters and setters like everyone else, right? Because I am hardcore. This is always going to be in the range of 0 to 100, period. But to me, it's like, well, if my kids want to change it so that it has to be in the range from 0 to 200, let them. You know, they can override set foo, they can override get foo, they can override foo, whatever. They can, like, let them. Like that's why we do inheritance, so they can make changes. So it's philosophical. So yeah. Okay, so now we've got class B that inherits from A. And again, the colon public is how you do inheritance. So class B is inheriting from class A. Okay. So that's a learning point, and protected is a learning point for today. Okay. Now, class B it copies and pastes. All the stuff in here gets copied and pasted into B. All of this is going to go into B for free. All right. It's just free real estate, right? And so B has, the B movie has an integer, int foo. It's got one of those, right? It has one because it's an A. Everything that's in A gets copied in for free. But you can change things. Like right here, we're changing the get foo function. So instead of being a simple like return foo, it's actually going to return foo plus 100. I don't know why we want to do that, but whatever. This is overriding the parent function. And you can use the override keyword here to make sure that you're actually overriding something. This guy is not set as const, so we're not actually overriding it. Oops. Oh no, no, get foo is on the bottom. Never mind. There we go. Everything's correct. Const right here. Right. Get foo is const. Get foo is const. Okay. And so this keyword here makes sure that we're overriding something, because people forget like the const keyword all the time, and if you do that, you don't actually override the parent. It has to be an exact match to override it. And so the override function is actually very important. And when you're making something that's going to be overridden, you use the virtual keyword here. So in general, everything on the parent is going to be marked virtual. Everything on the kid that is overriding is going to be marked override. That's the rule. So everybody in chat, please say all the methods on parent are virtual. Take a drink of coffee. All methods on a parent are virtual. On a coffee. It's a dark day for humanity. And then, good, all methods on the parent are virtual. And then all methods on a child are override. That's the general rule of thumb. You don't have to follow it. Technically, if you don't mark anything override, nothing bad is going to happen to you. It doesn't do anything. It just makes sure that you're actually overriding something. All methods on a child are override. Good. Okay. So let's go through this. So we've made a variable here named Alice of type A. Alice has a foo. We can't access it from main because it's private, or it's protected. It's like private. We're setting its foo to be 10 like that, and then we're going to print out its foo like that. So what value is this going to print to the screen? So remember, these are just standard getters and setters. So we're setting foo to 10, and then we're going to print out get foo. What value is this going to print to the screen? 10. It's an A. This thing here is a B, right? We're not, when you override something, it does not change the parent. You're making a new class. You're making a new class that has a different get foo. The old class is still the same. And so this is, in fact, going to print 10 to the screen. Okay. Now we're making B Bob, right? And these names, Alice and Bob, come from cryptography. If you're ever wondering why I always use these variable names, there's always this notion that Alice has a secret, right? And Alice is trying to send a secret to Bob, and there's this eavesdropper named Eve that's like trying to listen in on this. Okay. 8 in, Bill. I like it. I like it. Okay. So does Bob have a set foo method? Like, let's see. Bob here is a B. I don't see the words set foo anywhere on here. Will this code compile? Is this valid C++? Does it have a set foo for free from A? Yeah, it does. Yeah, very good. So yeah, you can call set foo because it just gets it for free. Everything that's on A, it has for free. Cool. All right. So, and then when we see out bob.getFoo, this is going to call this getFoo, not the one from A, because we've changed it. We've overridden the parent. We copied and pasted everything, but we've made changes. And so what value is this going to print out? So his foo is 10. So what value is going to get printed out here? Yeah, its value is 10, but when you call getFoo, it will print, good, you guys got it, it will print 110 because it has been overridden. Okay. And then if we're going to call bob dot get bar, what is that going to print if we had that there instead? If we call bob get bar, what value is that going to print? 42, good. What if we tried calling Alice dot get bar? Could we do that? Does the A class have a get bar method on it? Yeah. Alice is an A. They don't have a get bar function, and so it will not work. It will not compile. Okay. It will give you a compilation error. Okay. So yeah, basically, private and protected are pretty close, except private protects the variables even from the kids. Okay. You can also do something called multiple inheritance. I'm really not a fan of multiple inheritance. Like, let's say you're making a class hierarchy for animals. For some reason, everybody always talks about animals when we do this kind of stuff. So you could have a class for flyers, and you can have a class for like swimmers, and you can have a class for like walkers, and maybe each of these has like different functionality in a game, right? And then, can anyone think of an animal that can both fly and swim at the same time? You did the exact thing in inheritance. Yeah, for whatever reason, like I've job interviewed people, and I'm like, talk to me about inheritance, and like literally everybody just uses animals or shapes. Shapes or animals are like the examples everybody always gives, and it's like I don't think I've ever like non-ironically written code using that. A duck, yeah, okay, sure. So if we made a duck class, we could have the duck class inherit from both the flyer and the swimmer, and I think they can walk too, right? I don't see why not. Ducks can walk, so you can have like the duck class inherit from like 3 classes. And you can do it like this. So you could say class duck, colon, public walkers, comma, public flyers, comma, public swimmers. I'm really not a fan of this. Like I said, when I took CSI 40 and 41 at UC San Diego, they're called CSE 10 and 12 there, I really got into object-oriented programming. And I was like, wow, this can do everything. Like, we can just composite different classes together and just mix and match them all together, and it's great. And then I went into the real world and tried actually making real products using these complicated object-oriented hierarchies, and I went, wow, this sucks. This is actually really hard to implement in practice. Like, the number of bugs that you get and the complexity of trying to keep track of everything. Like, the pendulum on me swung the other way, and I'm like, I'm doing C programming now. Everything's a struct. Instead of having inheritance on a duck or whatever, I'm going to have, I'm just going to have a Boolean called, can fly, and a Boolean called, can swim, that kind of stuff. And So I actually really hated object-oriented programming and inheritance for a long time, and now I'm somewhere in the middle. So there are times where like I'm like, yeah, okay, yeah, inheritance is the right tool for the job. I am, however, very dubious of the people that are like making these huge conspiracy theory looking, charts, because I've done it professionally for years, and the costs outweigh the benefits, in my opinion. Okay. Uh, these classes were land before time. Duck inherits from the fish class. A rectangle is not a square, but a square is a rectangle. Yeah, exactly. So basically, here's when you use inheritance. So my dubiousness aside, like I do use inheritance, like not ironically, like for realsies, sometimes, not a lot. So if you have an existing class and you want to add functionality to it, but you can't change the base class, then inheritance is your guy, right? Can you guys name any classes that you're not allowed to modify? Why code duck inheritance when you just cat CGA? Just do the DNA directly. So anything in std, right? Anything in std you're not allowed to modify. So if you want to modify like the std vector class so that it doesn't like initialize the values, you cannot modify it. It's not allowed. Yeah, so if you want to add functionality, if you want to change functionality on some things, like the constructor doesn't initialize the values for speed reasons or something like that. This is a real world example. Yeah, std. Like people use std vector all the time. So like if you want to have std vector like not act a certain way, or an even better example, pop, like we were talking about pop last time, which deletes the top of the list, or can animals not be modified? So pop in the standard library segfaults if you have an empty whatever data structure. There's a lot of data structures in the standard library that have a pop method, and if you call pop on an empty data structure, it will segfault. And I don't like that. I actually don't like it when my code crashes. I actually would prefer getting an exception thrown, or like die, or like an error message or something, other than just the code going and dying, right, with the segfault. I like it when it like dies cleanly and tells me like, hey, or just print a message or return 0 or something, right? Anything other than just like, And so that's the standard library, right? And so like I actually started looking into making a safe version of the standard library that wouldn't segfault, and then I found out, of course, somebody had done it already. I'm like, okay, cool. And so that's the standard library that you guys have by default on the server. You guys by default on the server have what's called the safe standard library that actually does bounds checking and things like that. You actually don't have the normal standard library. You're welcome. So if you guys if you try calling like pop on an empty stack or something like that, it'll actually print an error message. Like you can't do that. So, but that's not the normal std. So you want one function to be able to take parameters of similar type without having to overload the function a billion times. Yeah, like I said, in Unreal Engine, there's this actor class, and the actor class is like 500 children classes. Like it's crazy. So instead of having to write like a different function for like pawns and characters and actors and all this kind of stuff, you can write a function that just takes an actor, and then any child of the actor class will work with it. So that's nice. You only have to write the function once instead of 500 times. Okay. So there you go. So that is the power of inheritance. The one thing that I kind of touched on that actually needs a little bit more detail on is this part right here. So when you make a child of a class, there's actually two different ways of doing this. You can actually use like using to pull the parent class's constructor in, but this is probably more common in practice. This is calling the parent's constructor. Okay. And I've got an example on the server that I kind of whipped up for you guys so that you can kind of see what this looks like. So I made a rectangle class in the 12 o'clock section. So it's got a minimum x, maximum x. It's got a constructor that just initializes the 4 values. I didn't bother writing getters and setters. I just wrote an area function that just computes the width times the length and returns it. Then I made a colored rectangle class that inherits from. I don't know what that's complaining about. It inherits. Like, does this not compile? Valid use. Oh yeah. How about that? Okay. There we go. Okay. So the colored rectangle class inherits from the rectangle class, and it's got one additional member value, which is the color that it is. The constructor here takes a color and it takes a min x, max x, min y, max y. It initializes color to be a new color, and then it calls. This is what I wanted to show you here. So it calls the parent class constructor rectangle, passing in new min x, new max x, new min y, new max y to the parent constructor. And so it does not call the constructor by default. There's another way of doing it with using, but this is probably the most common way you'll see people do it. And so it's initializing its own new thing here called color, and then it just passes on all the other parameters in the constructor to the parent. And then the parent constructor gets called and initializes all of those values right here in this absurdly long initializer list up there. And then the color rectangle class has its own draw function that draws the rectangle to the screen. Down here, you can see we've got a variable called R of type rectangle. You can print out the area of the rectangle. Colored rectangle, you can also print out its area because every colored rectangle is a rectangle. But then you can also call draw on it. And so there you go. It draws a 10 by 10 rectangle to the screen. And so you can use this to, should probably have blanked it. Like my face is like bright red now. It's crazy. Let's reset the colors. That's a little obnoxious. Okay. There we go. That's better. All right. So we now have something that you can draw to the screen, and you can use this to, if you want to do, you could do animations, like you could clear the screen and then draw the rectangle one spot over, and then clear the screen and draw the rectangle one spot over, and you can have one of these 10 by 10 rectangles bouncing around the screen like the DVD logo from The Office. If you guys have ever seen that episode. Like this. You guys might be too young for this, but we used to have like these like DVD players, and these rectangles would like kind of bounce around the screen like that. So using the colored rectangle class here, you could probably write that code. Just every frame, just change the minimum x and maximum x. And I mean, I don't have getters and setters, but you guys are smart enough to do it. And so you just change the min x and max x and min y and max y and have it bounce around the screen, changing colors occasionally every time it bounces. Could be a fun little exercise for you guys. I'll put this up into copy.cc into public colored rect.cc. So if you guys want to copy that, that's where it is, and maybe you can have some fun. How smooth would it be? If you're clearing the screen and redrawing, it's actually going to flicker like this because it's clearing and redrawing, and so it's going to and it's going to look really annoying. So what you actually want to do is just erase the difference of the rectangles when it moves. So like erase, draws black the column and rectangle it's not on anymore, and draw in as red the column and row that it is on now. And then it'll smoothly animate. Clearing and redrawing is, or you could just lower the frame rate so it only clears and redraws 20 times a second. Then it won't flicker as badly. But yeah, you could, depending on your network speed, you could probably have 400 frames a second. This thing bouncing around pretty smoothly. So show the triangles. Yeah. Okay. So 3D animation. So this is for IS50B. You can see the flickering here because it's clearing and redrawing every time. But these are actually 3D rendered triangles, and you can see them interpenetrating each other. They're z-buffered using barycentric coordinates to have a color gradient between the different points on the thing. And so every frame, it's animating the endpoints of the triangles. You'd see sometimes one's on top, sometimes the other one's on top as they're kind of moving in 3D space. And so that is our day for today. You've got a long weekend coming up. You've got Friday off and Monday off. So if you guys are not in a group now, join a group, and if you guys need a group, post on the chat channel right now and group up. And we only got 5 minutes left in class, so just group up and start working on it. Like I would. You want to join a group? All right. So if you need a group, post now. Maximum group size of 3. And if you guys are watching this recording later, then just post on the chat channels and put yourselves into a group. Looking for a group? Yeah, that works too. Okie doke. So I'll end the stream now, and I'll hang out for the next 5 minutes trying to get you guys all sorted out. Okay.